Okay, this is math made very, very easy. So what do we have now? We shall say cos. Let's maintain A. Whenever there is a B, you're going to change and call it very good and A. So you have plus what? A equals, let's go together. We are here, does it change? Does it change? Obviously no. We have our cos A. Then cos B. Our B is changing to what? To A. Very nice. So we shall say cos A minus, all right? Someone is saying, but sir, now, how are you getting the minus? Remember in the proof we made, or we discovered that for cos, compound angles in cosine, the sign always changes. If you had a plus sign here, then it's going to be a minus. If we had a minus, it would become a positive or a plus. So we shall have now our sine A, again, sine A. Obviously, we understand that cos A is the same as what? This is the same as saying cos squared A. Because, 2 times 2 is the same as saying 2 squared. 4 times 4 is the same as saying 4 squared. So cos times cos is the same as saying cos squared. We have it that way. We have a minus sine squared A. This one, ladies and gentlemen, is giving us our beautiful cos 2A. Have you got it? Now, this is the foundational identity for the cos double angle. Supposing A was equal to theta, supposing A was equal to theta, it will be implying therefore, it will imply therefore that cos 2 theta. Just change where there is an A and put there theta. So you have cos 2 theta equaling what? Equaling cos squared theta minus sine squared theta. Don't take me to prison for doing this. All right? This is very, very, very beautiful mathematics. I love math. So let's go. This one here is a very, very, very important identity. Very, very important identity. Remember, cos behaves differently. And in this sense, therefore, by playing with cos squared and sine squared, remember from our Pythagorean identities? We're going to apply that and get two more identities representing the cosine of a double angle of theta. How? We come and say from cos squared theta plus sine squared theta equals what? Who remembers that one? Cos squared theta plus sine squared theta equals 2. How? Very nice. Equals 1. So we have 1 around here. We know this identity very well. Now listen. We want to first and foremost eliminate cos squared theta. You see, our cos 2 is going to be obtained and going to leave it like that. But we want to eliminate cos squared theta. Obviously, you're going to come here and make your cos squared theta the subject. How? You're going to take this positive sine squared, isn't it? That one is going to go the other side. Obviously, you understand if it's a positive, it's going to become a what? A negative. Obviously, we know that once this has been pulled and it's no longer there, we only remain with a cos squared theta here. And then when it goes the other side, it's going to find there 1. So we shall say that our cos squared theta would be equivalent to 1 minus sine squared theta. Do we agree? Supposing we had called this equation number what? Number 1. Okay? So we're going to substitute in equation number 1. So we come and say in 1 or in equation 1. In equation what? 1. What are we going to have in equation 1? Remember, we are removing cos squared. We are substituting for cos squared theta. All right? To obtain the second identity. So we shall have what? We are going to have our cos 2 theta will be equal to what? Remember, our cos squared theta is now 1 minus sine squared. put it there the way it is. Let me change this and we see. We have what? 1 minus sine squared theta. This is representing our cos squared, which was up here. But we have our minus sine. Write your squared very well. Don't write like I've done it. Let's write it nicely so that it looks like really it's a square. We have that. Hope that is beautiful. Now, when you look at this one critically, you go